linear probing is one of the simplest method to resolve a collision. So here we are doing a sequential search. So whenever a collision is occurred, we will search. If the collision is occurred at the ith position, we will search from. Yes. Okay. If a collision occurs at location I, then we will search from I plus 1 the location onwards. And one of the most disadvantage of this method is that clustering means some key values. Key values may be clustered as a large group. And this type of clustering is known as primary clustering. Primary clustering. Primary clustering is the tendency for a collision resolution scheme such as linear probing to create long runs of filled slots near the hash position of key. That means most of the keys will be crowded at some end. If the primary hash index is x, subsequent probes go to, if a collision occurs at x, then we will search from x plus 1, x plus 2, x plus 3 and so on. And the result in primary clustering. Once the primary cluster forms, the bigger the cluster gets, the faster it grows and it reduces the performance. Let's consider one example. So at 52 location, there is one initial probe. Initial probe means there is a, actually it means that there is a collision. So here we are having a collision at location 52. So we cannot store another element at 52. So we have to search from 53 onwards. Actually at the location 53 also we are having another key 833. At the next location 54, we are having another key 413. So like that search is going on. So at the 57th location, we can store it. So that means the numbers are stored from 52 to 58. We know that 57 is empty, so we can store the newly arrived key at this location. So from 52 locations, from 52 to 58 are already filled. So that means the elements are stored at particular end. So this is known as primary clustering. Actually, we have 50 and 51, the locations are vacant, but we cannot store the number at this location. Usually numbers will be stored at a particular end. So as half of the hash table is filled, there is a tendency towards clustering. That is, key values are clustered in large groups. Thus, sequential search becomes slower and slower. So, look at this case here. Half of the table, more than half of the table is filled. If more than half of the table is filled, then there is a tendency of clustering. So here, more than half of the table is filled. So there is a chance of clustering. So after filling this 57, most of the elements are stored at this particular end. This particular end. So this is the disadvantage of linear probing. Some solution to avoid this situation. What situation? Which situation? Tell me. Solutions are there to avoid clustering. First one is random probing. Second one is double hashing or rehashing. And third one is quadratic probing. So first one, solutions to avoid clustering are random probing. It will avoid primary clustering, then double hashing or rehashing, then quadratic probing. So first one is random probing. What do you mean by random? Random means, so from the word itself we can say that linear probing. Linear probing means the searching in the sense, how did we search it? The previous case, we had done a sequential search. So we had done a sequential search in the case of linear probing. Random probing means what we have to do? Random. Linear means we are doing a linear search. Random location randomly. That is the main idea. This method uses a pseudo-random number generator to generate a random sequence of location rather than ordered sequence. So here we are not using ordered sequence. We are using a random sequence. So we will select the position is between 1 and x. So I equal to 1, I plus m mod x plus 1. So here I is a number in the sequence. and M and H are relatively prime. Relatively prime means GCD of M and H equal to 1. So we are choosing two prime numbers. M and H must be prime number. What is H? Can you tell me? Hello, what is
Size
H?
of the
Yes, size of the hash table. So H is the size of the hash table. So H must be a prime number. And we have to select another prime number, M. So another condition is the GCD of M and H must be 1. So GCD of M and H must be 1 means there must not be any common divisor between M and H. Okay, assume one example, M equal to 5 and H equal to 11. And initially I equal to 2. So pseudo random number generate the sequence. Suppose the pseudo random number will generate the sequence 8, 3, 9, 4, 10, 5, 11, 8, 6, 1, 7, 2. So stop producing numbers when the first location is duplicated. So that is one solution. So we are generating a random numbers from this sequence and we can stop producing numbers when first location is duplicated. Okay, next method is double hashing. So in order to avoid clustering, first method is random probing. Random probing means the hash function is selected using two prime numbers, that is I plus M mod H plus 1. This is the hash function we are using. In the next case, double hashing. Here, even random probing is not free from clustering. Actually, this random probing is used to avoid primary clustering, but it will eliminate clustering in some sort, but perfectly it is not a good method. It will eliminate a few clustering. So in the random probing, we are having another type of clustering known as secondary clustering. So if same sequence of location is generated from two different keys by the random probing method, then secondary clustering takes place. So an alternate method to avoid secondary clustering is to use a second hash function in addition to the first. So collision resolution technique, first one is linear probing. We are avoiding collision using sequential search. In the case of linear probing, the disadvantage is that it creates primary clustering. So in order to avoid primary clustering, three solutions are there. First solution is random probing. Random probing means we are generating random numbers and find the locations. But again, the disadvantage of random probing is that it creates secondary clustering. Secondary clustering means same sequence of location is generated for two different keys by random random probing. So in order to avoid the secondary clustering, we are generating another hash function in addition to the first one. Actually, we are having the first hash function, h1 of k. One example is there, h1 of k equal to k mod h plus 1. That is first hash function. And the next hash function is h2 of k equal to k mod h minus 4 plus 1. That is, it will generate another hash function m. So h1 of k equal to k mod h plus 1. This it will generate 1 I, and h2 of k equal to k mod h minus 4 plus 1. It will generate another key, another index m. Okay, one example, like h equal to 11 and k equal to 50. Our key value is 50 and our first hash value is 11. So first hash function h1 of 50 equal to, how will you calculate it? h1 of k equal to k mod h. What is the value of k? Tell me. What is the value of k? 50. What is the value of h?
11.
11. 50 divided by 11. What is the value? 50 divided by 11. 50 mod 11. Yes. 50 mod 11. 50 mod 11. 6. 6 plus 1. 6 plus 1 is 7. And h2 of k. So h2 of k, again, k is value is 50. h2 of 50 equal to k. K means k value is 50. 50 mod h minus 4. What is the value of h?
11.
11. 11 minus 4. That is 7. So 50 mod is 7. 50 mod 7 value?
1.
1. So 1 plus 1. 1 plus 1 means 2. So we got h1 of 50 and h2 of 50. Okay. Actually, h1 of 50 is 7 and h2 of 50 is 2. So h1 of 50 not equal to h2 of 50. Thus, h1 and h2 are independent. And also, we have to note that the m equal to 2. M means the second hash function. And h means h value. So m and h are relatively prime. That means there is no common factor. So this is how we can perform double hashing or rehashing. Now we can use this m value in I equal to I plus m mod h plus 1. As I equal to, what is the value of I? Initial value of I is 7. Because h1 of 50 is 7. So initial value of I is 7. So I equal to I plus 2 mod 11 plus 1. So then the random sequence will generate 10, 5, 10, 2, 5, 8, 11, 3, 6, 9, 1, 4, 7. Actually, the number may vary. So next is secondary clustering. Secondary clustering is a tendency for a collision resolution scheme such as quadratic probing to create long runs of killed slots away from the hash position of key. So again, the clustering means the elements will be grouped at one end. So here, primary hash function is at h means we will search. Process means search. Search starts from x plus 1. Here it is quadratic probe. Quadratic probe means we are not searching the next location. That is, in the previous case, in linear probing, we had searched x plus 1, x plus 2, like that. But in the case of quadratic probing, the incremented value is not 1. Here, quadratic means we have to add. Tell me which number? Actually, it is like this only: x plus 1, x plus 4, x plus 9, x plus 16, x plus 25. How did you got the increment value?
Square of
Yes, square of numbers. That is, in the first case, we got x plus 1. 1 square is 1. So, x plus 1. In second case, the number is 2. So, 2 square. So, x plus 2. 2 square. X plus 2 square means x plus 4. Next one is x plus 3 square. X plus 3 square means it is x plus 9. Next is x plus 4 square. That is x plus 16. Like that, we have to continue. So, secondary clustering is less severe in terms of performance it than primary clustering. So, primary clustering is worst, and secondary clustering is better than primary clustering. And it is an attempt to keep clustering from forming using quadratic probing. The idea is to probe more widely separated cells instead of those adjacent to the primary hash site. So this is an example. So suppose initial probe. Initial probe means at location 7, we got a collision. So first we will, in the case of linear probing, we will search for the next location. That means we will search 8, then 9, then 10, then 11, like that. Here the condition is, first we will search at x plus 1. X plus 1 means here x location is 7. 7 plus 1 means 8. First we will search 8. Then the next location is x plus 4. That means 7 plus 4. What is 7 plus 4? 7 plus 4. 11. Okay, after searching 7 and 8, we will go for 11. We have to search 11 is vacant. So which is the next location to be searched?
7 plus 9.
7 plus 9. 7 plus 9 is 16. So after 11, we have to search the 16th location. Here it is written the distance. Here it is 1. X plus 1 is searched. After that, x plus 4 is searched. This is 4th location. After that, we have to search x plus 9. This is x plus 9. So actually, you have to notice this case. 12th location is vacant. But if we are using quadratic probing, we cannot store the element at the 12th location. If you are using linear probing, then you can store the element at 12th location. If you are using quadratic probing, then the next element cannot be stored at 12th location. Next, quadratic probing is a resolution technique that eliminates the primary clustering problem of linear probing. In linear probing, if there is a collision at location 1, then the next locations will be I plus 1, I plus 2, etc. But in quadratic probing, the next location to be probed are I plus 1 square, I plus 2 square, I plus 3 square, etc. Here also, hash table is closed. What do you mean by hash table is closed? Tell me. Actually, closed means the hash table is considered as circular. That means after last position, we have to search the first position. Open hashing means it is like a linear array only. After last location, we cannot search the first location. That's the difference between open hashing and closed hashing. Okay, next one is open hashing, or otherwise it is known as chaining. The closed hashing technique deals with arrays as hash table. The main difficulties of this method are very difficult to handle the situation of table overflow. In some cases, table overflow will occur. So it is very difficult to handle this condition. Also, the key values are intermixed. Thus, the majority of the key values are far away from their hash location, thus increasing the number of probe, which degrades the overall performance. Since the numbers are far, we have to increase the number of searching steps. So it will degrade the performance. To resolve these problems, open hashing or chaining method is used. Here, hash table consists of an array of pointers, and each pointer points a linked list. So advantages of this method include an overflow of situation never erases. So if you are using a linked list, then overflow situation never erases. So the hash table maintains list which can contain any number of key values. Then next one is collision resolution can be achieved quickly. Also, insertion and deletion is also faster. This method is suitable where number of key values varies drastically. So disadvantage of chaining is extra storage required for field values. This is an example. So hash function is key mode 7. So this is our initial table. Key mode 7 means 7 is the size of the hash table. So 0 to 6. This is our initial hash table. Keys are 50. 50 mode 7. What is the value? 50 mode 7. Value 1. So at first location we are storing 50, then 70, 700, 700, 700 mode 7. Answer
0.
0. So we will store 700 at 0th location. 76. 76 mode 7.
6.
6. So sorry. 76 mode 7. So we will store at 6th location. Then comes 85. 85 mode 7. 85 mode 7. Answer
1.
1. So already 50 is stored at first location. So we can use a linked list like this. So 85 is stored at first location. So we are using a linked list to storing 85. Then next number is 92. 92 mode 7.
1.
1. So again, there is a collision occurs. So again, we are adding another chain. So this is a linked list. So we add 92 like this. 73. 73 mode 7.
3.
3. Again, one collision occurs at third location. So we will add a, sorry, actually there is no collision. After inserting 101 only, 101 mode 7. We
3.
can write 73 directly. 10 more 7 answer is 3. So we are having a collision. So we are using a linked list like this. Okay. Any doubt? Any doubts? So any doubt? Any doubts? So this one is an example for a collision resolution technique. So here another example is given 25, 42, 96, 101, 102, 162 and 197. Again the actually the table size is 7 only. 7 numbers are there. So we can use a hash table of size 7. So numbers are 25, 42 like this. These are the numbers. These are the numbers. So hash function is 25 more 7. 25 more 7 means you got 4. 4 means you can store 25 here. So this is how we are in the previous case at this location, location 1, we are having 2 numbers. So instead of storing like this, we are storing the index value here. Here we are storing the index value, and from the index value we are using a linked list to store all the key values. If there is no number, we can use a null value like this. The next important factor is load factor. Load factor alpha equal to number of elements present in the hash table divided by total size of the hash table. So load factor represents the average number of elements at each table entry. For open hashing, load factor is always between 0 and 1. For chaining, load factor can be greater than 1. So these are some comparison, separate chaining and open addressing. Separate chaining is simpler to implement. Open chain addressing requires more computation. Separate chaining hash table never fills up. We can add more elements to chain. Open addressing table may be full. Separate chaining less sensitive to the hash function or load factor. Open addressing requires extra care to avoid clustering and load factor. Fourth point, separate clustering is used widely when it is unknown how many and how frequently keys may be inserted or deleted. Open addressing means it is used when the frequency and the number of keys is known. Separate chaining means wastage of space. That means parts of hash table in chaining are never used. In open addressing, slots can be used. Separate chaining uses extra space for links. In open addressing, no links are used. So application of hashing. Compilers use hash table. You will study compiler in the next semester. Actually, there you are using hash table to keep track of declared variables. A hash table can be used on online spelling checkers. If there is any misspelling, it will detect. Then it is used in game playing programs. Then it is used for quickly check for inequality. That means if 2 elements has 2 different values, they must be different. So these are the application of hashing.